So we have this radical expression, and we are asked to simplify this using exponential notation. In calculus, you're going to see that certain things you want to do, half of them is very unpleasant unless you're using the exponential form, and the other half is very unpleasant unless you're using the radical form. So in calculus, you're going to have to be able to quickly move back and forth between the two forms using this rule. If you have a rational exponent, that is the same as a to the nth power, taking the mth root of that, or the same thing but in different order, take the mth root of a and then raise it to the nth power. So this is the rule that we're going to use. So we can rewrite this where, so here is how you remember it. Grab a number that's greater than 1, like 2 or 3 or 5 or 10. When you're exponentiating that number, you're growing them, sort of moving up. And when you take roots of numbers, like square root of 100 is 10, square root of 9 is 3, then you're shrinking them, you're moving downward. In this scenario, the number that exponentiates, that's the number that tells you how to go up, goes up. And when you're taking the root, that's when you're shrinking the numbers, moving down, that goes into the denominator. So that's just one way to remember it. We can simplify this fraction because both numerator and denominator are divisible by 4. The numerator is 3 times 4, and the denominator is 5 times 4. And now going back to sort of this radical notation, so the number upstairs tells you how much to go up, and the number downstairs tells you how much to go down. And then just to be sure, we use the same order, so first exponentiation, then root. I'm sure there is a way to go from here to here, but I think it would take some work. So this is one example where we can see the usefulness of this notation before we hit calculus. Thank you for watching.